Thank you. Kia ora koutou and good afternoon. Welcome here today to Te Whare Wanaka Ora here at Lincoln University and this Lincoln University Excellence Series. The Excellence Series provides an opportunity to showcase research excellence at Lincoln University and explore the ideas, discoveries and expertise that have helped shape the future of Aotearoa New Zealand land-based sectors. Today, we turn attention to New Zealand's most distinctive and internationally recognised, one of the most distinctive and internationally recognised land-based industries that associated with wine. Wine is often talked about in terms of place, vintage, variety, and craftsmanship. But behind every glass is a remarkably complex world of science, and we'll hear about that today. The chemistry and microbiology of grapes and wine influence everything from colour and aroma to flavour, texture, and stability. Understanding these processes is not simply about understanding what is in the glass. It also has important implications for how we produce wine, how can industry address practical challenges, improve quality, and make better use of the resources that we have available. To take us behind the scenes today, we're delighted to welcome Associate Professor Ben Tian from Lincoln University. In just a minute, please. Ben's research sits at the intersection of wine science and microbiology. His work encompasses the role of macromolecules, such as proteins and polyphenols in grapes and wine yeasts and lactic acid bacteria and the metabolites they produce, and the potential to extract value from winery waste, including grape commerce. We welcome Ben Tian here today to address us as part of this excellent series.
Thanks, Brent, for the kind introduction. Actually, over the past few days, my friends and colleagues heard that I was going to give this talk. Most of them asked me the same question. Would there be a wine tasting for you? So actually, let me ask you a question first. How many of you here for the science today? Great. I see a few hands. And don't worry. Also, I haven't forgotten all those wine lovers because I brought a bottle of wine here. So this is a best of wine of 2026. Made from our students' micro-vinification projects this year. And this is the best Pinot Gris we just selected a few weeks ago. So we can open this bottle and we can taste it during the social session later after my presentation. But first, let's talk about the science. So when we talk about New Zealand wine research, we can't really skip Sauvignon Blanc, because Sauvignon Blanc is really important, probably the most important variety for our New Zealand wine industry. Why is so important? Because the production of Sauvignon Blanc is huge. It's almost 80% of total national wine production volume. And also almost 90% of wine exported overseas is Sauvignon Blanc. So it's really important for our wine industry, also for our government revenue as well. For most of you, you probably know the typical style of Sauvignon Blanc, especially produced from Marlborough. It's always give you a very fresh, very fruity, high acidity. You got this typical citrus fruit. You can also got a lot of tropical fruit as well, like pineapple, like passion fruit, like guava. You also got a little bit of green and herbaceous aromas as well. But before we smell and taste the wine, there is something even more basic. What does the wine look like, right? So for a lot of consumers, the first judgment for wine quality happens even before the glass reach our nose. So this is the first topic I'm going to cover here. It's about wine appearance. So when people buy a bottle of wine, a bottle of Sauvignon Blanc, people would expect a glass of crystal clear white wine, right? You probably don't really want to drink a bottle of wine or glass of wine like this one. The one on the right-hand side of this photo, it looks really cloudy, really hazy. And the problem for that haziness or cloudiness is because the proteins in the wine. Those proteins are naturally present in the grapes, and they can survive through the very harsh fermentation conditions. If we don't remove those proteins, and if we don't really have very stable storage conditions, for example, temperature fluctuation, those proteins could slowly delature and form the haze in the bottle. And at the end, what you can see is also haziness or cloudiness in the wine. So in the commercial wine production, what winemakers can do, they use bentonite to fine the wine. Bentonite is insoluble, it's type of clay. So when people use bentonite to fine the wine, those bentonite can absorb the proteins. But the drawbacks for using bentonite is not specifically absorbing proteins. Bentonite can also absorb some beneficial aroma compounds, flavor compounds. So when you're adding a lot of bentonite, you could remove all those proteins, but at the same time, you might also remove some beneficial aroma compounds. What's more importantly, once you have done the bentonite fining, you have to remove the bentonite. So when you do this process, you could end up losing up to 2% of your wine volume. So there is a study estimated the value due to the bentonite fining based on the global white wine production volume as almost like $1 billion US. So how we can minimize the use of bentonite or even replace bentonite for protein stabilization in white wine is probably $1 billion research question. But to address those questions, we might need to have a better understanding what are those troublemakers, what kind of proteins we are really talking about here. So these are the two major proteins we found in Sauvignon Blanc juice and wine, stomatic-like proteins, and also chitinases. Those proteins are relatively tough. Like I mentioned, they can survive through the fermentation process, which is quite harsh conditions. It's very low pH, got a lot of high acidity, and also relatively high alcohol content as well. So for a lot of proteins, they cannot survive through this process. Most of the proteins, they either precipitate or delature already during this fermentation process. But for those two groups of proteins, stomatic proteins and the chitinases, they can survive through the fermentation process, and they are the troublemaker to cause the protein stabilization issues. But these two groups of proteins are also related to plant defense systems, which means grapes can produce those proteins in response to environmental stresses. So this also led us to conduct some experiment to figure out the impact of different environmental stresses on the concentration of those proteins in the grapes. So the first trial that we did, it was about powdery mildew, which was one of the most common fungal disease in New Zealand vineyards. So we separated the grape skins and the pulp, and to figure out where those proteins distribute in different grape tissues, and then to see how those the protein concentration can be influenced by different level of infection of powdery mildew. So you can see from this table, when those grapes, Sauvignon Blanc grapes, when they were infected by powdery mildew, the concentration of both stomatic-like proteins and the chitinases are increased significantly. If you focus on the grape skin of those infected grapes, you can see even more clear trend. The more severe the infection, the higher the concentration of those proteins in the grape skin. So biologically, that makes sense because, like I mentioned, those grapes are also related to plant defense systems. So when those grapes are affected by powdery mildew, they will produce more of those proteins to fight back against those fungal disease. Another trial we did is to use polycarbonate plastic to block out UVA and UVB, then trying to see how those UV radiation can also influence the concentration of those proteins. So what we did here, we have control, which is no blocking of UVA and UVB, and the treatment is UV excluded. So you can see from the picture there, when you block out all those UV radiation, you get very nice, clean, grapes. If you have those UV radiation, sometimes you get a lot of sunburn on the surface of grapes. And then if you look at the concentration of those proteins, once you reduce the UV radiation, the concentration of those proteins has been reduced significantly as well. So which means UV radiation can also trigger the biosynthesis of those proteins as well. So this gives us a lot of information for the producers If you want to minimize those proteins in your juice, in your final wine, you probably need to do better vinegar management to minimize those proteins in the grapes in the first place. We then follow through the development of those proteins during the grape ripening stage. So you can see both proteins gradually accumulated during grape ripening stages. And then we analyze a lot of juice and wine, trying to figure out a potential correlation between those proteins and the bentonite requirement. Compared to the somatin-like proteins, we found the catechinases are showing much more positive correlation with bentonite requirement, which means if you have more catenase, this type of proteins in the juice or in the wine, you will need more bentonite to achieve protein stabilization. So this probably gives you a very strong indication. If you see more catenase, you probably need to add more bentonite. So this is probably all the useful information for winemaker to manage the level of proteins in the grapes, in the juice, and in the final wine, in order to minimize the bentonite requirement for the protein stabilization. But if we really want to replace or find some alternative to bentonite, we might need to have a better understanding the protein haze formation mechanism in white wine. So this is the proposed mechanism for protein haze formation in white wine. So under normal conditions, those proteins are soluble, so they are fine. You won't see any haze or cloudiness in the wine. But when you have unstable storage conditions, like increased temperature, those proteins are going to gradually unfold and then self-aggregate to form some complex, and at this, due to the hydrophobic attraction, and at this stage, some other wine components, they can get involved as well. For example, phenolics or tannins, like a sulfite, which is normally added into the wine during the winemaking process, and also some metal ions like copper and iron. They could all help cross-link those self-aggregated proteins into much bigger particles. When those particles become bigger and bigger, when they're bigger enough, they become the haze, and people can see those in the cloudiness and the haziness in the wine. So at this point, you might just wondering if the proteins are the problems, right? The troublemaker. Why can't we just add some, enzymes or proteinase to degrade those proteins? Easy, problem solved. So that is very logical, thinking and also solution as well. But unfortunately, for a very long time, the researchers just cannot find a very efficient proteinase that can degrade those proteins at wine, conditions. Like I just mentioned, very high, very low pH, high acidity, and normally we have to store the wine at a very low temperature as well, maybe around 15 degrees Celsius. So under such conditions, there's very limited enzymes or protease can effectively degrade those proteins. Until very recently, there is a research group from Australia. They found a fungal acid proteinase called aspergillopepsin, extracted from Aspergillus niger, this fungus. So these proteases have shown some promising potential to degrade both somatin-like proteins and the catenases, especially when you combine this enzyme addition with a short period of heat treatment. So for example, you can just using those enzymes at a Jewish stage, and maybe 1 minute heating treatment at 70 or 75 degrees Celsius to breaking down all those somatin-like proteins on the catenases. So this is another tool provided for winemakers to manage those those proteins, to achieve the better protein stabilized white wine. So this also where the story started to move in a slightly different direction for me, because in my early research, I spent quite a few years working on proteins in Sauvignon Blanc. So you can imagine during my research, I have tasted a lot of Sauvignon Blanc, hundreds of Sauvignon Blanc, and sometimes I feel, maybe I have done enough tasting of Sauvignon Blanc. Let's make a change, do something different. And then I was thinking about the interaction between proteins and tannins. And then tannins are very important for red wine. So why don't we just do some research about red wine? And then I tried to focus my research slightly from Sauvignon Blanc to Pinot Noir. which is another very important grape variety for New Zealand wine industry. It's also most planted red variety in New Zealand as well. But in terms of the production volume, that's nowhere near Sauvignon Blanc. So you can see here, the production volume for Pinot Noir is just about 6% for the total wine volume produced in New Zealand every year. But if you think about the quality perception by the consumer, by the wine professionals, Pinot Noir is extremely important for our industry. Because I think if we talk about the world level, the highest premium high quality wine, you have to talk about Pinot Noir from New Zealand. Actually, for some Pinot Noir from Central Otago, from Martinborough, they can be as good as those top examples from Burgundy, where this grape variety originally coming from. So for that, in that sense, Pinot Noir is really important. And for red wine in general, color and tannins are very important. Like I just mentioned, a lot of consumers, they judge wine quality by judging the color of wine, right? So that's why for red wine, color is also very important. Tannin is important because tannin can contribute to the body, to the texture, to the structure, even the aging potential for the wine. But tannin extraction also needs to be very carefully managed. When you have too little tannin extracted into the wine may taste a little bit thin and simple. When you have too much tannin extracted into the wine may taste, especially depending on the type of tannins, the wine could be tasted really harsh, bitter, or too astringent, as not really indication of good quality as well. So Pinot Noir winemaking is always about the balance. How much is enough, or how much is too much, right? And that's a very typical question for all the Pinot Noir producers. How do I produce an elegant, Pinot Noir wine by having good, color and also structure without over extracting those tannins or colors? So that's a very typical question for a lot of Pinot Noir producers. So this is where my early protein research become an interesting topic, because I thought if proteins can interact with tannins, could removing those proteins increase the extraction of tannins in Pinot Noir wine? So this is a very simple idea. To test this idea, we used a very advanced piece of equipment, the coffee plunger. So for very small scale of winemaking research, coffee plunger is really useful. It's quite useful. Sometimes you don't really need super expensive equipment, because we want to handle very small amount of grapes and also in a very controlled conditions. So coffee plunger is perfect for that purposes. And the trial we did was really simple. We just used those proteinase I just mentioned earlier. Normally we use for white wine, but in this case, we use those proteinase in Pinot Noir production, and we added at 2 different dosage rates, at 15 ppm and 50 ppm as well. And then we evaluate the tannin in the final wine. So you can see from those graphs, as long as you add enzymes into it, you can see very significant increase in tannins. The more enzymes you added into the wine, into the grapes, the more tannins you can get in the final wine. We also evaluate the size of tannins, because the size matters. So we also evaluate the size of tannins by measuring the MDP, mean degree of polymerization. So why the size of tannin matters? Because when you have a bigger size of tannins, they normally give you more astringent sensation. If you have relatively smaller size of tannins, you will perceive more bitter taste on the palate. So that's why the size of tannin also give you very different sensation in the mouth. So if you look at the graph on the right-hand side, when you're using a lower dosage rate of enzyme addition, there's not much in the difference in terms of the average size of tannin. But when you use a high dosage rate of enzymes, you're gonna have much smaller average size of tannins in the final wine. So this is also very useful information for the winemaker. Yes, proteinase is very effective. That can help you to extract more tannins, but the size of tannins is really depending on how much you are going to add into your wine. If you're adding a lot of enzymes, you might end up with much smaller tannins. Is that a wine kind of style of wine you want to produce? This is probably a very important consideration for the producers. Protease is not the only tool that we can use to manage tannin extraction. There's also a very traditional way that we can think about to increase the tannin extraction in Pinot Noir. So instead of adding something into grapes or into juice, we choose not to remove something from the grapes. And the stuff that we try not to remove is the grape stems. So this is also called whole bunch fermentation. It's not really new concept for making Pinot Noir, because from Burgundy, also in a lot of regions in New Zealand, many Pinot Noir producers, they use whole bunch fermentation to produce Pinot Noir. Because they all found when they including some whole bunches, whole clusters, they can have more tannins in the final wine. But a typical concern or kind of an issue problem associated with whole bunch fermentation is a lot of producers they found when they include whole bunch fermentation, they also got a lot of green and herbaceous aromas in the wine. For Sauvignon Blanc, maybe it's okay, a little bit green or herbaceous, but for Pinot Noir, we don't really want green or herbaceous aromas. This always indicate underripe, lower quality. So that's always very classic wine science question. For winemakers, they want all the good stuff from grape stems, but they don't want those bad stuff coming together with those grape stems. So that's why for this reason, we want to better understand whole bunch fermentation more scientifically. That's why we collaborated with Pixels Bay Winery in Whitebrow to work on this project. What we did in this trial, so we included two different grape clones, AM10x5 and UCD5. Those are the very typical clones planted in Pixels Bay vineyard. We also included two different levels of a whole bunch. So the control, there's no grape stems involved at all. Then we have 30% of whole bunch, 60% of whole bunch. And then we, again, made a wine in our Lincoln University winery and also compared it with those commercial wine made at Pixels Bay as well. So you can see from this figure, as long as you include more whole bunch, the tannin concentration increased quite a lot, but wine color also decreased quite a lot as well. I think the main reason for the decrease in wine color is because when you have those grape stems involved in the fermentation, they can also absorb some pigments. So when you finish winemaking, when you do pressing, removing all those grape stems, they can also remove some pigment, some color from your wine. That's why you see the increase in tannin, but decrease in the color. From the aroma perspective, you definitely see more increase in those green herbaceous aromas with a little bit of increase of floral and a spice aroma as well. And then there's also some difference between the two clones. In general, the AM10x5 showing more tannin and color with a little bit more floral aromas. The UCD5 showing a little bit more fruity and green and herbaceous aromas. The following question for us is trying to understand why. We're not really surprised, we have more tannins in the wine because we have grape stems involved. But the thing is that we want to know how much extra tannin we can get from the grape stems. So we try to quantify the tannins from different grape tissues, from the grape skin, from the seeds, from the stems. Surprisingly, the tannin level in grape stems are quite substantial, comparable to all those tannins you can get from grape skins, but lower than the grape seeds. What's more interesting here is not about the amount, the absolute quantity of tannin is one thing, but another thing is how easy those tannin can be extracted from your grapes into your wine, right? So then we also assessed the tannin extractability as well. And then for this part of results, it was also quite surprising. The grape stems, the tannins in grape stems, actually the easiest ones to be extracted, much easier than the tannins from the grape skin. And the grape seeds, actually those tannins are the most difficult to be extracted. That's also why when you're making your red wine, most of the seed tannins were extracted towards the end of fermentation because you have more alcohol already present in the wine. Those alcohol, those solvent can facilitate the extraction of seed tannins. That's probably the reason to explain why you end up with more tannin in the wine. So anyway, these results definitely confirmed grape stems can be a very reliable and the efficient source of tannins. If you want to have more tannins, definitely you can consider to include grape stems or even including some whole bunch in the fermentation. But the grape stems not only brings the tannin, they also bring some other chemical compounds into your wine. That's why we start focusing on those green and herbaceous aromas. What kind of chemical compounds could contribute to those green and herbaceous compounds? Then we focused on those chemical compounds called methoxypyrazines. So we found that those methoxypyrazines present at a very high concentration in the grape stems with a little bit of concentration in grape skins. So when you have those grape stems or whole bunch included in the fermentation, you will get more tannins, but at the same time, you will also get more extraction of those green aroma compounds into your wine. But good information for winemaker is we also monitor the development of those green aroma compounds during grape ripening. So the riper the grapes, we found those in the green aroma compounds decrease quite a lot. So this probably depending on how mature the grape stems are and how much liquefied those grape stems are. So if you have a more mature grape stems, more liquefied, you will end up with much lower those methoxypyrazines, much less those green aroma compounds. So this, again, give the winemaker a lot of information to decide whether or not you should use whole bunch or how to use the whole bunch. In general, we say, if it's a very warm vintage, you have very mature and highly liquefied grape stems, you could use whole bunch, even use higher percentage of whole bunch, because this can give you more tannin, but a minimal extraction of green aroma compounds. If it's really cool, really cold vintage, definitely try not to use whole bunch. Try to avoid to have any grape stems involved in your fermentation. Otherwise, you do get a little bit more green tannins, but more importantly, you get those negative and herbaceous aroma into your wine, which can collectively affect the overall quality of your Pinot Noir wine. So far we have talked about how to manage the protein level, the tannin level, whether or not we should use the grape stems. So if you really want to make very distinctive, high quality Pinot Noir wine, I think we should think about something beyond what's happening in the winery. So this takes us, probably we have to think about where those grapes are coming from. And this probably takes us to, for me, is one of the most romantic concepts in wine world, which is terroir. Terroir is a French word, just like many other French wine words. If we don't translate it too directly, it sounds much more elegant. But in the short term, terroir means a sense of place. It includes a lot of things. It includes climate, topography, the grape variety, the soil, the plants, the animal, human management in a vineyard. This is really something that can make one vineyard very different from another vineyard. This is also why the French people say, you guys can, no matter how advanced your technology is, you will never able to produce whatever we can produce because we have a unique terroir. These high quality grapes can only be grown in this place. You can't copy paste our terroir. But anyway, I think it's a very interesting concept and also very challenging to study the terroir because it covers so many aspects. We can't really, normally when we do research, for me, sometimes I always feel like in this way. It's like you have a masterpiece in a room. But when you do research, you probably can only pick through a window. You can see part of that masterpiece, but you will never get a chance to see the whole piece from the different angle and walking around the masterpiece. So this is the same thing for studying terroir. We can only focus on maybe one or two aspects, but we were never able to study everything at the same time. So the way that we approach this concept, do some research, we used two case studies here. The first case study was done in cooperation with Greystone in Winebrown. So at Greystone, they have done this very innovative winemaking back in 2016. Because we said, a lot of, I think everyone agreed, the best wine should be expressed the terroir, where the grapes are planted. So the chief winemaker, Don Maxwell, just got this idea from back in 2016. He thought, if expression of terroir is so important Why not we just do the fermentation in a vineyard? If we harvest grape, take the grapes back to the winery, the influence of terroir just stopped. But if we put fermentation tank into the vineyard and do the fermentation in the vineyard, so all the influence in the vineyard, all that environmental influences, whatever terroir includes, is all going to be captured during the fermentation period. So they start doing that from 2016. And for the first time when I heard this kind of idea, I thought, oh, that sounds a little bit crazy. So I went to their cellar door. I did a tasting of their vineyard fermented Pinot Noir, and I liked it. It was really beautifully made and very different from the winery fermented Pinot Noir. So I would just start talking with Dom and saying, this is really fascinating. We should do some research because personally, I want to know more why they are so different and what could be the causes and how different they are. That's why we started collaboration from 2017. And then we did some trials focusing on the two vintages, 2019 and 2020. So the first thing we want to look at is the yeast diversity and abundance, not only at the beginning of the fermentation, but all the way through the end of fermentation. So you can see from this figure, at the very beginning, there's not much difference in terms of the yeast diversity or abundance. But when you have the fermentation going on, you see those long Saccharomyces, the percentage of those long Saccharomyces always showing higher level in the vineyard fermentation system. So for Saccharomyces, those are quite important yeast. Those are the ones actually doing the most of the alcoholic fermentation, get the job done. But the long Saccharomyces yeast, they are also very important. They might not, really doing a lot of job to converting the sugar into ethanol, but they can produce some beneficial aroma compounds and make your wine smell or taste more complicated, more complex. So that's why, those long Saccharomyces having a higher percentage probably is a positive thing for the final wine. And then when we look at the chemical composition in the resulting wine, the first thing we notice is the big difference in color. So when you have Pinot Noir wine fermented in the winery, they're always showing more intensity in the color. And so in the vineyard fermented wine, they're also showing lighter in color. Then we also analyze a whole range of aroma compounds. Among all those aroma compounds, the most distinctive differences we found are a group of compounds called esters. So those chemical compounds closely related to yeast activities during the fermentation. And those ester compounds normally contribute to fruity aromas. And we found two particular ester compounds, hexoacetate and isobutyl acetate. They are showing much higher level in vineyard fermented Pinot Noir wines. And those two compounds normally described as apple, pear, or banana aromas. So this probably also matches very well what we observed by tasting over there. We do find the vineyard fermented Pinot Noir showing much more fruity aromas, lighter in color, but softer tannin, softer texture as well. Another ester compound we found is ethylcanoate, but this one showing lower level in vineyard, and this chemical compound normally described as oily or waxy aroma or flavor in the wine. So definitely, when you just simply change the fermentation location, this not only just change the yeast community, but also significantly influence the final wine chemical composition as well. Another case study was done in collaboration with Felton Road in Central Otago. Actually, this is the PhD project, which is here as well. So this is her PhD project. She's about to finish probably in 1 or 2 months. Very soon, okay. So this is another good example about the expression of terroir. At Felton Road, they have 2 vineyards, 2 biodynamic vineyards, Calvert and Cornish Point. Both vineyards were established around the year of 2000. So they have same selection of grape clones, same selection of rootstocks, and they try to do very similar vineyard management practices. So almost like everything quite similar between each other. But every year they just found the grapes, the wine are very different. Both vineyards can produce a very high quality Pinot Noir. The retail price for both vineyards, those Pinot Noir, probably about $100 in New Zealand. So very high quality wine, but in very different styles. So I just asked the same question, why? why they are so different, what could be the causes. That's why this is also how we started collaboration. I approached the winemaker Blair and say, let's do something. Let's help you to understand better your vineyard expression, your grape, your soil, maybe your wine as well. So what we took soil samples around grapevines, not only analyzing the soil physical chemical properties, we also analyzed the soil microbes around grapevine zoo area. And then we also analyzed a range of grape berry compositions, and also we made wine to analyze the final wine composition as well. I know this figure might look a little bit terrifying, too complicated, and this probably kind of figure makes people start checking their phones. But don't worry, the key message I want to deliver here is we do find some strong correlation between soil and the berry composition, particularly the soil properties and also the bacterial community have much stronger correlation with berry composition. And the berry composition, we analyzed here many amino acids and also the phenolic compounds here. And then we had a look at the chemical composition in the final wine as well. The first thing we checked also the color. So when you focus on the Calvert vineyard, so they're always, no matter which rootstock we are focusing here, they're always showing much darker color comparing to Cornish Point. And then we check the tannin level and also the size of tannin as well. So the Calvert vineyard also showing much higher concentration of tannins. And also they tend to show bigger size of tannins in the resultant wine as well. So this might be, if we look back to the soil profiles in that vineyard, the Calvert vineyard did contain a little bit more clay in the soil. And the clay soil is quite well known to produce very bold, very big, very concentrated, red wine, especially for Pinot Noir. That's why for a lot of premium vineyard sites in Burgundy, they try to find some sites with higher content of clay. This probably part of the reason can explain why we see darker color and the higher concentration of tannins, and also a little bit larger tannin in the resulting wine as well. We also had a look at the aroma profiles. So you can see these are the 4 groups in each vintage. The purple and the blue colors are the 2 groups coming from the Calvert vineyard. The green and orange are from the Cornish Point. So you can see definitely based on the aroma profiles, those 2 vineyard samples can be separated very well. But the rootstock could also play a role in different vintage. In 2023, we see a better separation between the 2 rootstocks for the Calvert vineyard samples. But in 2024, we see better separation between those 2 rootstocks for the Cornish Point vineyard. And also the vintage also play a role there as well. So this is a very complex system, but overall, we can confirm that the different vineyard sites, different soil profiles, different microbial diversity, abundance, this all come together influence the final wine composition and probably come to the conclusion that terroir expression, it is very important. If you don't really know what the site can give you, you don't really know what you should express in your final wine. So this is probably some useful information we can provide to the winemaker. I think that's all for my talk today. Just before I finish, I would like to say, for quite a long time, I think Lincoln University's core missions are feed the world, protect the future, and live well. And I think our research fits very well into the last one. If you can't really remember anything from my talk today, at least remember this: live well, laugh often, and drink wine. Last but not least, I will just quickly thank all my students and colleagues, my current PhD student Ziyu, and also previous PhD students Pradeep, Grace, Jingwen, my colleagues Roland, Stephen, Jim, Romy, Leandro, Richard, Jason, colleagues from BSI, Manfred, Claire, and also Belinda from the UK, and very importantly, industry partners Storm, Ivan, and Blair, and all the founders. Thank you so much.
Thank you very much. Opportunity for some questions now. Oh, that's right. I'll set off then. The difference between vineyard fermentation and normal winery fermentation, there's clear differences expressed there. You got any hint what it is? Is it fluctuations in microclimate, temperature?
We think so. Actually, we also monitor the temperature as well. Actually, if we just check the average temperature day by day, there's not a big difference. But the maximum temperature and the lowest temperature during the day and night, it is bigger in the vineyard. This might be also the driving factor for those differences in yeast community. Yeah, but eventually it's the yeast, producing those metabolites to cause difference in the wine. Yeah.
Yeah, so I was going to the impact of temperature and rainfall, amount of water, and a wet summer versus a dry summer, and those sort of impacts.
I think temperature definitely influence, but in terms of rainfall, so we just had a look at those. It's okay. So if it's a sunny day, they just put in a sieve on the top, just to avoid any bugs or leaves getting into the fermentation. If it's a raining day, they will put a hard cap on the top, so there's no rain to get into the fermentation. So I think probably still from the environmental factors, temperature fluctuation may be more relevant in that case. Yeah.
But would that then impact plant vigor? If you've had high rainfall, whatever, presumably you've got juicier grapes.
Yes, in terms of grape growing season, also you're talking about the fermentation stage or the grape growing.
Both.
Yes, rainfall have a huge impact. Even though if you have too much rainfall just before harvest, they can easily dilute the flavor in the grapes. So that's why in the industry we don't harvest grapes straight away after rainfall. We have to wait 2 or 3 days, sunny days, to dry out a little bit. Then we harvest grapes. Otherwise, a lot of things going to be diluted in the grapes. Yeah. Yeah.
What is the biggest challenge making wine in the vineyard?
Labor. They have to shift all those tanks into the vineyard, and also the space between the rows is very narrow. So you can only put very small tanks. So this is really suitable for small, boutique, style of wine producers. For those big commercial wine producers, they will never try this, even though they think it's very interesting. But no, thank you. Too small. So that's why when we do this, you see it also in wineries we collaborated. They're all relatively small, but because they're small, that's why they only focus on quality. So I think for us, when we do research, I think quality is way much more important than quantity. That's why you see my collaborators, not many of those big producers like Independent or Delicate, because they produce massive wine at the entry level. It is important in some way, but for me at the moment, I'm more interested in quality production.
The cloudiness of the Sauvignon Blanc, is that pure cosmetic, as in people don't like the look of it, or does it also have an influence on the taste or the time of storage?
Actually, there's no much impact on the sensory. If I give you black glass, one is clear, one is already cloudy or hazy by the proteins. People won't tell the difference. That's also why nowadays you probably heard people talking about natural wine. Natural wine is unfined, unfiltered. They always look cloudy and hazy. But for some people, if they're familiar with that concept, they don't care. But for some consumers, if they don't really have much wine knowledge, this wine looks so bad, so cloudy, so hazy, it's not good. Yeah. So that's why for those massive producers, they still try to clarify, remove proteins, make sure it's always look crystal clear.
And it doesn't have an influence on how long you can store the wine or how it matures.
If those proteins have been removed, definitely you can store for longer and no haziness. Even though if you have proteins in it and you store for longer, you see some haze, but this doesn't really change the quality of your wine. As long as the consumer, they don't mind a little haziness or cloudiness or the appearance. Yeah.
At Greystone, did Don prefer the vineyard produced wine or the winery?
I asked the same question.
Yeah.
Both are his babies. So,
Did the public
so
prefer either or is it's obviously a good marketing thing?
probably half, because for them, I think their marketing strategy is not trying to say which one is better than the other one. It's more about providing different styles and just tell the consumers there's just two different styles. The both are very
They can
good.
buy both and compare.
Exactly. Yeah. So ask the same question, but he's both are pretty good.
Peter, and then over here.
As a soil scientist, I've always wondered, what soil mineralogy might affect, how it affects wine quality or grape development.
Yeah.
But just really the fact that it's place and location and the heating and the cooling is far more important at diurnal fluctuations than and just the drying characteristics of the soils, because you can grow some pretty great wines in some pretty terrible soils. And so, but is there any evidence to show that what the soil is actually made of, apart from that, just basically moisture holding capacity?
Yeah, I think that's very interesting topic, because like you just mentioned, normally for those good wines are produced from very poor soil. So grape is not wine grapes is not like any other crop. They don't really like very fertile soil. If you give them very fertile soil, the quality of those grapes, the quality of those wines never be good, because you really want those grape wines to struggle. You want their roots go really deep, trying to find a nutrient, trying to find a water source, and then the flavor or the aroma going to be more concentrated in the berries. That's why the quality of grapes or wine going to be better. Back to your question about what kind of soil properties can correlate with wine quality. From that, the figure, if I remember that complicated one, I remember the CEC, the cation exchange capacity, showing quite a strong correlation with berry composition. And like I just mentioned, the clay, the content of clay, if this soil is more clay contained soil, or is more like a sandy, this have a huge influence on those chemical compounds in the wine, in the grape and the wine as well. In general, we believe the clay soil can concentrate more in a tannin, more structure. But if you grow your grapes in a more sandy soil, so because they're very good it doesn't have very good water holding capacity, so the grape wine probably go a little bit deeper. In that case, they can show more aroma and the flavor compounds in the grapes. There's some kind of correlation between the soil and the grapes in the wine. Yeah.
Yeah, I was wondering, when you were looking at stem tannins, did you look into the effect that lignification has on the extraction rate of the herbaceous compounds?
I don't look. Just see how much, like in the brown part, it's just on the end, or the brown, color all the way go down to the branches. Yeah, but not really. We don't really know how to access, access the liquefaction. Just by usual check, this one showing more brown color in the stems. Maybe they have higher liquefaction levels. Yeah. Yeah.
And did you see? Was there any sort of difference in vineyard practices that would lead to greater or lesser lignification?
We didn't analyze any data, but in my thinking, I think for example in the vineyard, when you do canopy management, if you have more sunlight exposure, this probably can accelerate the liquefaction of stems. So probably also related to the temperature, depending on how you are managing your canopy, you can create the microclimate, the temperature around the branches. This probably all can influence the liquefaction level in the grapes. This might be something else we can look at in the vineyard here. Yeah, thank you.
Thank you. Tony?
You also get a haziness in beers. Is that due to the same issue?
Definitely due to proteins. I don't know if it's due to the same groups of proteins. So those haziness in beer is also proteins. And also the foam in sparkling wine, the foam in beer, also because of the proteins and also peptides, amino acids. If you remove all of proteins or those peptides, amino acids, you won't get so much foam in the beer or in sparkling wine.
Haziness in beer is often seen as a positive feature.
Yeah, that's why we can't get any fun in the beer industry. Yeah.
Thank you. When you were talking about bentonite, you mentioned that it takes out some of the beneficial flavors as well.
Yeah.
Have there been any sort of trials done comparing not using the bentonite and having a hazy end product versus, and because the hazy one should actually taste better, shouldn't it? If it hasn't had any of the volatiles
Some studies have compared, untreated wine versus bentonite fine wine. They do find, bentonite fine wine losing some aromas and less preferred by consumers or wine professionals. So someone have done that, yeah. So there is some, impact. That's why, people try to minimize the use of bentonite. Yeah.
An opportunity for one or two last questions. Sharon, please.
Yeah. And of all the research you've done, where do you see as the greatest opportunity for New Zealand wine to be able to go forward? And given the shrinking market, what are the features that we should focus on to be able to sell good prices?
Somehow to persuade people drinking more wine. That's why last time, live well, love often, and drink wine. If everybody just drinking more wine, we have no worries for the future. But I think, for me, I think it should be quantity, because the production volume for New Zealand is too small. We can never compete with quantity. It's always quality. Every time when I go back to China, talking to those wine drinkers in China, when they think about New Zealand wine, it doesn't matter which producer, it doesn't matter from which region. People will think, as long as this is from New Zealand, this is better quality, this is good quality. This is really important image you want to sell to your consumers. It doesn't matter the region, it doesn't matter the producer. The overall quality for the whole country is good. Yeah, so I think that's quite important for us to maintain in the future.
And on that question, I think it's appropriate to finish and to thank them for an excellent presentation, taking us through that journey of wine science and quality of wine, emphasizing how those combined approaches of detailed lab analysis, as well as that in-vineyard type approach to experimentation, can shed really real useful insights into wine quality. And thank you very much for your presentation. Got a little gift here. It's not wine. We're actually using olive oil at this point in time. So thank you very much. We still have in the foyer for some
Tasty students wine.
Thank you very much.